Welcome to the Python Programming Language Live Lessons. I'm David Beasley, and I'll be taking you on this guided tour of the Python programming language. I've been using Python for more than 20 years, and am the author of the Python Essential Reference published by Pearson and the Python Cookbook published by O'Reilly. For the past 8 years, I've been teaching Python courses to professional software developers. Prior to that, I was an assistant professor of computer science, where I primarily taught courses in operating systems and networks. This course aims to cover the essential features of Python programming through a series of practical programming examples. I assume that you are already a programmer and are familiar with programming concepts such as control flow, functions, and data structures. To get the most out of the lessons, it will be helpful to have some prior Python experience. Most of the examples are more advanced than you would find in a typical tutorial for absolute beginners. However, if you are new to Python but have significant experience in another language, you will be able to learn the essential parts of Python at a more accelerated pace. It is important to note that each lesson is focused on a big idea rather than exhaustive coverage of every possible detail from the reference manual. In each lesson, I address a specific practical problem and demonstrate the solution through code. I explain the steps being performed and why I am taking a particular approach. In addition, solutions are written using a modern Python style and programming idioms used by experienced Python developers. However, don't expect every possible corner case or esoteric detail to be covered. In some sense, the lessons are a springboard to initiate further discovery through books or online documentation. In the first few lessons, we start by using Python to perform data analysis tasks such as reading files, building data structures, and performing calculations on that data. These first few programs then serve as a starting point for thinking about code organization and generalization. This takes us on a journey into object-oriented programming and some of the issues surrounding code reuse and extensibility. Later lessons dive into some of the advanced techniques used by frameworks and libraries to control the programming environment. This includes meta-programming features such as decorators, descriptors, and meta-classes. Finally, the course concludes with an overview of generators and coroutines, one of the more interesting parts of Python that can be used for a wide range of applications, including data analysis and concurrent programming. So let's get started. In this lesson, we look at the basics of working in the Python programming environment. This includes starting and stopping the interpreter, using the interactive console, editing and running programs, and how to turn simple programs into useful scripts. Getting help and some basic debugging tips are also described. In this first part, I'm going to look at how to start and stop the Python interpreter and work in the environment. And first things first, Python is normally a command that you would run at the terminal or a console. So if you're on a Unix machine, you would type a command such as Python 3, and that would bring up the Python interpreter. Well, once the interpreter is up, it's something that you can actually experiment with. You can start typing in commands, and this actually turns out to be one of the most useful parts of Python, this interactive environment where you can experiment with it and get immediate gratification on things that you want to try. A few things about this environment, just to get out of the way first. The triple greater than is Python asking you to type a new command. So if you see that, it's asking you to do something. So you can type something in and see the result. If you type something and you get triple dots showing up, like in that for statement, it means that Python wants you to continue typing what you just did. So it's actually waiting for me to continue with what I just started. So I might type another command in there. Again, I would get triple dots. It's waiting for me to type some more. In order to get that code to run, you just have to hit return. So if you enter a blank line, you'll see the code run at that point. Again, this interactive mode, it's a great way to kind of interact with the language, use it as a calculator and experiment. A few other things about the interactive mode. If you want to save the result of something that you're working on, assign it to a name. So you could say something like A is equal to 42 times 10, and then that A becomes something that you can use in later calculations. So I could say B is equal to 5 times A. Another thing about saving results, if you happen to be using the interpreter, and let's say you didn't save the result that you just calculated, you can get to it by using the underscore variable. So underscore holds the result of the last thing that you did. That's actually a feature that's only available in the interactive mode, but it can be useful if you're using Python to do calculation, using it as your desktop calculator, for instance. If you need to cycle between previous commands, usually up and down arrow will work. So if you hit up arrow, you'll see it kind of cycling through previous lines. Down arrow will go in the opposite direction. Another thing that is available is there is online help. So if you saw me type something, you want more information about it, like help about the print statement or print function, you can say help print, and you will get a little bit of help information. To be honest, that help, it may or may not be useful. I mean, the official help for document or help for Python would be found on the website. So if you do need to get information about the Python language, you would probably want to go to python.org, and then there is a documentation site for that. Probably the most useful part of that might be the library reference. So you can get the library reference, and then it says, okay, keep this under your pillow. It's not lying about that. So that would give you information about everything that's kind of part of the language, and you can go there and get more information about things that you see. In terms of this course, I'm hoping that you don't actually have to rely on the help too much. But that is something that is available. Now, to get out of the Python interpreter, you can type quit, or you can hit Control-D, and that will take you out of the interpreter. So if you're just experimenting and you need to start and stop, again, you type Python 3 to start, either type quit or Control-D to get out. The final thing I wanted to talk about for getting started is just the problem of making a file. So let's say you wanted to make a file that you can run over and over again. To do that, you need to edit a program using your favorite editor. I use Emacs, but there are many options available. So what you could do is make a file like hello.py, and what you're going to do in here is put any Python statement that I've used so far into this file, and I will save this as a program hello.py on my machine. In order to run that, what you do is you just give this to the Python interpreter. So I'm going split screen here. The top is my program that I'm going to run. Down here I have the Unix shell. If I want to run Python on that program, I would give that to the Python interpreter. So I would say Python 3 hello.py, and you would see the program run. So this is a common way of making files, editing them, having them run in the interpreter. The Python Interactive Interpreter is actually one of the most useful features of the language, if you ask me, and I tend to use it all the time for experimenting and trying things out. And to motivate that, I thought I would do a more interesting example than just hello world. Essentially, the example involves my office. So my office in Chicago is located on Clark Street, right next to a CTA bus stop. One of the things that you'll find on these bus stops is they have information where you can text like a certain code in and find out when the next bus is going to arrive. And so what I thought I would do is an example of me getting that information from Python so I can find out when to hop the bus and head down to Wrigley Field, maybe catch a Cubs game. So to do that, what I've got the bus stop up above, and I'm going to fire up Python down below, and I'm going to interactively find out how long I'm going to have to wait at this bus stop for something to show up. I'll talk about some of the features that I'm using as I type. The first thing that I'm going to do is I'm going to import a library. So Python comes with a large library of modules for doing different things. This library that I've imported is something that can let me go out and fetch web pages. It lets me make HTTP requests out on the web. And I'm going to go to a site that the city of Chicago runs for tracking buses. I'm going to pull down a stop prediction from that. Don't ask how I got this URL, although you can find out online if you need to. But what I'm going to do is essentially punch in some numbers on here. So I'm going to make a request saying I want information about stop 14787. That's this little code down in the bottom with the CTA bus. And then the route is the bus route number on that. So I'm going to make a request, and if that works, I'm going to read some data back, and I'll get something that looks like that. Now that looks a little bit cryptic, but what I've got is a fragment of XML. that comes back, identifies itself as XML, and embedded in that XML there are stop estimations. There's these little PT elements that I could try to extract out of there. And so to do that, I'm going to load another module from Python. The statement here is another way of importing a library, and what I'm going to do is turn that data that I just read into an XML document of some sort. Don't worry about the details so much right now. What I'm going to do with that is I'm going to write a little query where I'll ask to go find all the PT elements in that data and then print out what their text is. So just doing the interactive Python interpreter, I have found out I will have to wait 7 minutes at this bus stop to go down the street, and then if I miss that bus, I'll get another one in 10 minutes and then in 20 minutes. This is the kind of cool stuff that you can do with this interactive mode of Python. I mean, again, you can try things out, you can experiment with it. It's like instant gratification. This is so much more compelling than just printing hello world, if you ask me. Now, because that might be a useful thing to do, I thought it would take that code and put it into a file. So, typing at the interactive prompt, that's great, but probably what you want to do is make a file that will do that instead. So again, if you want to make a program that you can run over and over again, you fire up your editor and you put those same statements into a file. So I'm going to, again, do the import statement, just loading a library. I'll make that request to go fetch the bus information here. Okay, again, just asking for a stop prediction from the city here. And I have to give the route number and the stop ID. Okay, so I'm going to make this request. We'll get the data. Again, I'm typing the commands pretty much the same that I did in the interactive interpreter down below. And then I'm going to go find all of the PT elements. Okay, so now I've got a little program, nextbus.py. I now have a program that whenever I want to find out when the bus comes by my office, I can run Python 3 on that next bus, and it will tell me, oh, okay, I've made a mistake there. Very common thing to make a mistake. What I forgot in the code is to do URL open. We'll talk more about traceback messages in a later lesson, but that's what happened there. So let's run the program. Now I have a different mistake. I have a typo in my URL. That error down below, it says 404. That's an HTTP error that you get if you go to a non-existent web page. So let's try it. Okay, so now I have to wait 5 minutes for the bus. This is kind of the kind of thing you would do to get started. That interactive mode, very useful for experimentation. Once you've experimented a little bit, put it into a file, and then you can run your file over and over again. In the last part, we wrote a script that found out when the next bus was going to come by my office in Chicago. And just to refresh your memory on that, the code that I'm showing here is that script. And then if I ran that, what it would do is give me the stop estimation, sort of saying when the next bus is coming. So it actually tells me that one is approaching right now, and I have to wait 9 minutes and 19 minutes. One of the problems with this program is that it is hardwired specifically to my office in Chicago. I mean, it only works for that one bus stop. That is the kind of thing that you might want to generalize. A lot of people use Python to write little scripts, little utility scripts and so forth, and they want to be able to use it on different data. So what I'm going to do here is modify this program to read the stop number and route number from the command line or from the Unix command line. And it's useful just to see how that works. So in order to do that, there's a module called sys that is part of Python. And inside that module, there's a variable called sysargv that has the command line options in there. I guess to start, let me just print out what they are. Command options, and I'll print sysargv. And then I'm going to make the program quit. This statement that I've got here, by the way, this is how you make Python just stop. So if you wanted a program to terminate earlier, raise a system exit. And so if I do that, what's going to happen is the program will let me pass different arguments on the command line. Like I could say Python next bus, 22.14.787. And what the sysargv is it actually holds these things that I passed on the command line. So here's what you can do to get that information out. I'm going to put a little check in here that just checks to see whether the number of command line arguments is not equal to 3. And if it's not, I'll print a little usage message to the user saying, hey, you have to use next bus, and then give it a route number and a stop ID. And then if it does look okay, what I'm going to do is pull out information from the argument. So it turns out the route number is the first argument. The 0 argument is the name of the program. So 1 is 22, and then I'll get the stop ID out of argument 2. And then instead of having those numbers hardwired into this URL, what I'm going to do is plug them in doing a little bit of string formatting. So I'm going to plug in the route number and the stop ID into that format method. And then what's going to happen now is I have this program working as a script. I can type next bus. I can put in a route and a stop ID, and it will give me information for that combination. What it would do is generalize the code where I can put in different stop IDs. I can go to different bus stops in Chicago. You know, if I wanted to find out like when the Route 6 bus would come by stop 5037, I could punch in that. So in some sense, I've made the code more general. Again, this is something that's very common in running Python. A lot of people use it to write little utility scripts, and they want to take input. It's an easy way to do that. The other thing I wanted to just show at this point is sometimes people want to have a script where it will run without having to type the Python command first. You know, in all of these examples, I have to type Python and then the name of the program. If you want to get rid of that, one of the things that you can do, at least on a Unix machine, is use what's known as a pound bang trick. You make an executable line at the start, say user bin environment, Python 3, and then you can make that program executable, and then that will become something that you can just run all on its own. You don't have to use the Python interpreter to explicitly run that. So this is some common things when writing scripts. It's useful to know when getting started. This is often how people start using Python, is in this way. Let's talk about some basic techniques for debugging Python programs. As you start to write code, you're going to make mistakes, and figuring out how to recover from those mistakes is a skill that will take some time to develop. So to do that, again, I have this program that we wrote in the last part for finding out when a next bus was going to come by my office. And normally when that program runs, okay, you type something like Python 3, next bus, 22, 14, 787, and you get a result back. If there's a mistake in the program, what is going to happen is the program is going to crash. So just to illustrate that, let me make a mistake in the program. I'm going to change a name in the program and run it again. If I run that with a mistake in it, Python will crash and it will generate a traceback message. Reading these traceback messages, the most essential part of it is that the very last line is actually what is wrong with your program. So if you're looking at the error message and you're saying, I wonder why that's not working, the very last line is what's wrong. Okay, it comes back and says attribute error, there's no attribute txt. And then right above that, it's showing a line of code from my program. For something like that, it might be as simple as like just a typo in a name. That's the mistake that I made, is I changed the name. You can fix it by fixing the program. You might have to consult the help or the documentation to do that, but it's like a simple programming mistake that has taken place there. Other kinds of errors are maybe a little bit more daunting. For example, let's say I went to this program and I made a mistake in the URL. Let's say I made a typo in that, and then I ran the program with that mistake. What's going to happen here is you're going to get a much larger error message. I mean, if you look at the error message, it goes on for line after line after line. It's very easy to look at that and become very intimidated. For something like that, you have to carefully look at the message that's being generated. First of all, the last line, again, this is what is wrong with the program. It comes back and it says, HTTP error 404 not found. And then what it's doing is it's showing a whole bunch of code in libraries that is not my program. Okay, these lines of code that it's showing, these are not part of my next bus program. And the way to maybe interpret that is that maybe I've given some bad input to a function. I gave it like bad input, it went through a whole chain of operations and then crashed. And so for something like that, I have to look at my program and look at the inputs to maybe the URL open function. The fact that this is reporting a 404 is telling me that the URL is bad. It's going to a non-existent URL. So that should give me some clue about how to fix that. By changing it back, I can get the program to work again. Now, some other programming techniques that I think are worth knowing about. Let's go back to the original crash here where I had a name problem like that. One thing that is actually very useful to do is to run Python with the -I option. You can say, well, what does that do? What that does is it will run the program and then drop you into Python's interactive prompt afterwards. This can be a very useful way to kind of poke around and look at what is happening. Like I can look at the data that came back. I can look at this document that's in the program. I could maybe try different experiments with it to see maybe I screwed something up somewhere. I mean, essentially what can happen is your program can crash, and then you can come back afterwards and poke around at it. That's one useful technique for debugging, is to know about the Python -I option. Some other techniques for debugging, obviously you can do print statements, like printing the text out here. That works fine for debugging as well. I mean, I can put a print statement anywhere I want and see what is happening here. Like if I wanted to see the response of that request, I could put a print statement in there and just view what happens. Okay, so now it's showing me the response. Another thing that may be useful is the Python debugger. Let me go back to my original error there. If your program crashes and you are using this -I option, one thing that you could do is load the debugger. So there's this module, PDB, that you can load. And if you do pdb.pm, which is short for postmortem, it's kind of a weird thing to type, it will take you into the code, show you the line of code where it failed, and then you can do poking around. You can do print statements from here. You can get program listings to sort of find out kind of surrounding context and so forth. Another thing that I'll mention, since it involves the debugger, sometimes you will see people launching the debugger in the code itself by putting this statement in here. I'll just put a comment next to it, launch the debugger. That is kind of like a manual breakpoint. Wouldn't say it comes up super common, but if you have a large program and you're just completely lost about what is happening, you might put that in the program, and what will happen is when you run the program, it will hit that point and then go straight into the debugger. At that point, you can poke around. You can maybe single step through the code if you want. You can make it run afterwards and so forth. So these are all tools useful to know about for debugging. As you start to write larger programs, it'll be useful to be able to do that.